Okay, on a modern vehicle, just disconnecting a wire at the coil may not be an option. For modern vehicles, we may need to disable the ignition system or the fuel system by removing relays, removing fuses, any number of different ways that it needs to be done. You need to refer to manufacturer information on how you disable an engine to keep it from running on a modern vehicle. Remember that spark plug I dropped earlier? Here it is. Since I dropped this plug, it's very important that I inspect the porcelain on it, make sure that the porcelain didn't end up being damaged when the plug dropped and hit the ground. We also want to take a look at the electrode on it, this ground electrode right here, and make sure that that strap isn't bent. Everything looks okay on this. This is a perfect example of a spark plug that is showing a rich running condition in this engine. This engine has way too much fuel going through it. That's why that spark plug is that black. It should not be that black. Ideally, we would want to see a much lighter color for a spark plug. So this engine clearly needs some tune work. Moving along to our compression test. We've installed the hose earlier, the adapter's in place. I now have the throttle linkage set so that the throttles are wide open and the ignition system has been disabled. At this point, I need to crank the engine. Generally want to crank the engine 3 to 4 times. And what we really want to watch when the engine is cranking is the gauge. We want to see how quickly this gauge comes up to a certain pressure. If the engine is in good shape, we're generally going to have a gauge jump up to a relatively high pressure very quickly. And then any other gains we make will be smaller and incremental. An engine that's not in very good shape, the needle might come up very slowly. So let's watch that gauge while this engine is cranked. Because the Schrader valve is in place on this engine, this is going to hold this pressure in the hose. If that Schrader valve wasn't in there, I wouldn't be able to crank the engine and then walk back out here and see where this is at. Now I'm showing roughly 100 pounds of compression on that particular engine. I'm not on that particular cylinder. I'm not that worried about that reading. The next thing that I want to do is I want to do another cylinder, preferably one that's not right next to the one I just did. And we're going to compare those values. So, release pressure in this gauge, disconnect the gauge, we're going to do a little bit more difficult cylinder. Plug wire off. Tight spark plug. This time I'm going to try and catch that spark plug so it doesn't hit the ground. Taking a look at that plug, it's also showing me a very, very rich condition. So at this point it's clear that this engine is quite fuel saturated. That fuel saturation may be part of the reason why we're seeing a compression reading that's slightly low. If we have a situation where there's a lot of fuel in the cylinder, the fuel will actually wash and displace engine oil. Engine oil makes some of the seal that we see in the cylinder, so if there's no oil or there's a low amount of oil on the cylinder walls, our compression reading is going to be low. The other thing that can create a low cranking compression reading are camshaft characteristics. This particular engine has a pretty large cam in it with a lot of overlap and a lot of duration. That can also very much affect cranking readings. All right, we're hooked up. Let's see if we can't get that gauge to sit somewhere. And we're going to crank it. Okay, we're roughly the same place. We're definitely within the 10% value that we had specified. We're right around 100 pounds. That tells me that even though these readings are somewhat low, at least they're consistent. We don't have to worry too much about a mechanical problem in that particular cylinder. That's how we run a compression test. The results that you read are really important for analyzing engine problems. If we have one cylinder that has a low reading in comparison to the rest of them, we need to evaluate that cylinder further. If I have two cylinders that are right next to each other that are low in comparison to the rest of them, evaluation a lot of times is going to indicate that we have a problem with the cylinder head gasket. Two cylinders next to each other with a blown head gasket will have low compression readings where everything else will be high. Individual cylinders, now we've got to evaluate those cylinders. If all of them are very low, then we're looking at, in general, just poor wear or a lot of wear in the engine. If you have a V-type engine and 4 cylinders are low and 4 cylinders are high, a lot of times we're looking at cam timing. The cam timing is moved, and the cam is no longer timed in relation to the crankshaft where it needs to be. So that's basically it on a demonstration on a compression test.